here we are with 9.3 and 9.4 study guide. The way you're going to use this is to fast forward and check your answers. If there are any items in which you get incorrect, you want to go ahead and rewind and listen to just that portion. Okay, let's take a look at the first question. In the complex plane, the x-axis is referred to as the real axis, and the y-axis is called the imaginary. Suppose z1 equals r1 ei to the theta 1 and z2 equals r2 e to the theta 2 are two complex numbers. Then z1 times z2. Okay, remember, if we're going to multiply two things, then the exponents are going to get added. So we're going to do r1 times r2. Both of them are times e to the I. And then inside that parentheses is theta 1 plus theta 2. All right. Determine if the statement is true or false and make the correction if false. If z equals r e to the theta is complex number and n is an integer, then z to the n equals r to the n e I theta. Okay, so something is missing in here. So this is false. And actually, this is based on de Moivre's theory, or de Moivre's theorem, where if we raise something to the power of something, it's going to end up z to the n is going to equal r to the n e I to the n theta, right? So it was this little n thing here that was missing in this one. Okay. All right. If z equals x plus yi is a complex number, then the magnitude of z is going to equal, that's just my x and y components squared. So x squared plus y squared. Now remember, we leave off the I because truly when you are finding the value of z, you're actually multiplying by its conjunction. So it ends up all washing out with your I and the negative that turns positive. All right, number 5, if z1 equals r1 ei theta 1 and z2 equals r2 ei theta 2 are complex numbers, then z1 over z2 is going to be equal to r1 over r2 times e to the I, and remember, it's your difference of angles. So theta 1 minus theta 2. All right. Next, we have plot the complex number in the complex plane and write it in polar form and in exponential form. So we have 1 plus I. So if I go ahead and make my coordinate axes, so there's one, there's another. I would have right here 1 plus I, right? Because this is my imaginary and this is my real. So the polar value is going to be this value right here, and then of course the angle that's there. So I would have the square root of 1 squared plus 1 squared, which is going to give me the square root of 2. And because I have 1 and 1, I can tell that this is a 45-degree angle, but let's go ahead and go through the motions of finding your angle. So inverse tangent of y over x is how I find it. So that angle is going to be the inverse tangent of 1 over 1, which is just going to be 1, and that gives me 45 degrees. And so that is actually in the first quadrant, so I don't need to do anything to it. But it's also equal to pi over 4. So I'm going to use that in my information here. So if I put it in this format, I have square root of 2 comma pi over 4. Now here it says the polar way to write the expression. Remember, that is your value, which is square root of 2, times the cosine of the angle, which would be pi over 4, plus I times the sine of pi over 4. So that's the format I'm using for that one. And then the number in exponential form is going to be RE to the I theta. So that's going to be square root of 2e to the I pi over 4. So that is our value for exponential form. All right, now on to number 7. Plot the complex number on the complex plane and write it in polar form and in exponential form. So we have negative 6i. So let's go ahead and create, let's see here. I'm going to put my axis here and here. And then I'm going to go ahead and plot negative 6i is going to be 1, 2, 3, 4, 5, 6. It's going to be right here, negative 6i. So if I'm looking at my polar value and direction, my r, right, is going to be the square root of x squared plus y squared. Well, I don't have an x value, it's only y squared. Well, the square root of y squared is just going to be y. So my value is going to essentially be the absolute value of negative 6. So r is going to equal a value of 6. And then I take a look at this, and if I go, I don't even have to do my inverse tangent on this one. If I go around, I will see that I'm at 3 pi over 2 as far as my angle is concerned. So my theta is equal to 3 pi over 2. And so the way I would write it is r comma 3 pi over 2. And then the polar way to write the expression would be 6 cosine 3 pi over 2 plus I sine 3 pi over 2. The number in exponential form is going to be 6e to the I 3 pi over 2. So there you go. A vector u for which u in the double bars, that's my magnitude. Okay, if my magnitude is equal to 1, then it's called a unit vector. Okay, then it's called a unit vector. And then if v is equal to AB is an algebraic vector whose initial points, I should say are at the origin, then v is called a position. Position vector. If v is a non-zero vector with direction angle, so this is our angle, alpha is our angle, and that's between 0 and 360 degrees, between v and I, then v is equal to which of the following? Okay, then this would be, remember when we have our format, our sign on the inside is going to be an addition, so that takes away these two things. Okay, so we have to look at what is associated with I and what is associated with J. The I is associated with X, which is the cosine, and J is associated with Y, which is the sine. So it's going to be this one right here. All right, use the vectors in the figure below to graph the following vector, v plus w. So I'm going to take a look at this first vector, and I have 1, 2, 3, 4, 5, 6, 7, 8. So 8, 0 is my position vector on that one. And I have 1, 2, 3, 4, 5, and 1, 2, 3, 4. So 5, 4 is my position vector on that one. So if I'm going to go ahead and plot this, I would do 1, 2, 3, 4, 5, 6, 7, 8 across. That would be my V. And then I would do my W. So I have 4 up and I have 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I believe this is that 5? And is that 4? Yep. Okay. So 1, 2, 3, 4, 5, and 1, 2, 3, 4. So that's my W. So my resultant vector would be this one that bridges both of them. So this is V plus W, okay? I guess it just wants us to graph it. If I wanted to find that value, what I would do is go ahead and add up those position vectors, right? So just as a quick review, my x total, right, that x total would be 8 plus the 5, so that would be 13. And my y total would be just that 4. So I would have, to find my resultant vector, it would be 13 squared plus 4 squared. So that would be 169 plus 16. So that would be the square root of 185. And I could go ahead and put that into a value, and then to get my angle, it would be the inverse tangent of my y, which is 4, over my x, which is 13. And it looks like it's in quadrant 1, so, and plus my x and y are both positive, so that would be the angle, actually, that this occurs. But again, that's more than what the question is asking for. Okay. All right. The vector v has an initial point P and a terminal point Q. So this is where it starts, and this is where it ends. Write v in the form of AI plus bj, that is, find its position vector. And if P is equal to 0, 0, which is the origin, then that means Q is my position vector. So all I have to do is just write that out. So my 8 would be my I, and then plus 9j. So that's an easy one. 14 is very similar, except my points are not the same. So I actually have to do some math here. So I'm going to look at my x value. And so I have 6 minus a negative 2. That's how I find my difference. So minus a negative is the same as adding. So it's going to be 8. And then my y value is going to be negative 8 minus negative 3. Minus a negative 3 is the same as adding a 3. So negative 8 plus 3 is negative 5. So the way I would write this is 8i minus 5j. All right, find v, or the magnitude of if v equals negative 7i plus 24j. So that is going to be equal to the square root of negative 7 squared plus 24 squared. And when you go ahead and square that up, you end up with a value of 25. And the reason I know that is because this is actually a Pythagorean triple. 7, 24, 25 is a Pythagorean triple. So v is equal to 25. And then last two, 16. If v is equal to 5i minus 7j and w is equal to negative 4i plus 2j, what is the solution to 4v plus 5w? All right, I'm going to go ahead and write this. So 4v and 5w. So 4 times 5i minus 7j and 5 times negative 4i plus 2j. So this is going to give me 20i minus 28j. And this will give me negative 20i plus 10j. All right, so if I'm going to go ahead and add those two together, if I take 20 plus a negative 20, that's going to give me 0. Negative 28 plus 10 is going to give me negative 18j. So this is going to be my total minus 18j, 0i. And then find the magnitude of v minus w if v is equal to 2i minus 5j and w is equal to 3i minus 6j. So the first thing, I put a little hint here. First, what we're going to do is perform the operation, and then we're going to find the magnitude of the new statement. Okay, so let's go ahead and find v minus w. So 2i minus 5j and 3i minus 6j. So we're going to subtract these. 2 minus 3 gives me negative I. And then 5 minus a negative 6 is going to be negative 5 plus 1j. So this will be negative I plus j. So that's going to be my term. Now remember that it's the equivalent of 1 for each of those because we don't have a value. So my value of v minus w is going to be the square root of negative 1 squared plus 1 squared. So that's going to give me the square root of 2. So that value of v minus w, the magnitude of that is going to be root of 2. And if we wanted to find the angle, we could do that as well. But seeing as you have a negative x and a positive y, that would be in the second quadrant and would actually be 135 degrees.